So as illustrated with the previous video and applet, we have the law of signs here in the ambiguous case where you're given certain parameters, namely 2 sides and a non-included angle. In this picture, which is similar to the picture you saw in the applet, you have a fixed angle, so I'll put a big letter A here. You have a fixed length provided for you, and the third parameter, I will show you the 3 scenarios that resulted. If the third side that's provided for you, so that in pink is too short to meet the initial side of the triangle provided, then what happens or what results is that no triangles fit that description. So you have a 0 triangle scenario. So 0 triangles exist, in which case you were provided the initial angle, the initial side, that side here, and then this third side is just too short to make an actual triangle from it. And so that's what you see illustrated on the right. If I were to then say, let's erase this pink, and let's say that the side is long enough to meet the initial side. One of the scenarios could be that one triangle exists from the given parameters. So you have the initial angle still being the same, the initial side being on the bottom, and then the third side being just long enough to make a triangle. So you have the scenario right now of 0 triangles fit the parameter. You could have 1 triangle, or the other option, and this is why it's ambiguous, is that you could actually have 2 triangles, and I will call it scenario or case 1 versus case 2. Okay, so I will erase the pink on the middle diagram and show you that if the third side that was provided for you was long enough to touch the third side but be equivalent to this other length right here, that fixed length you could think of it as if it swung to the left, you have the result being case 1 where you have an obtuse triangle. So I'm going to try to sketch that obtuse triangle over on the left right here. Okay, so you have A is given to you. You have now this is angle B1, which is formed when you swung the third side over towards the left. And then you have C1 being obtuse. Now, if you take a look at the 2 pink that I highlighted here, this is an isosceles triangle. So this side is congruent to this side. So that being the case, I know these base angles are congruent to each other. So the angle that is down bottom here, that's C1. That's my obtuse angle. So if I'm trying to figure out the second case being I have the same fixed side, I have the same fixed angle A, but this time the third side is equivalent to what I see over on my obtuse triangle, but it's swung the other way. And so the result is this triangle right here. So A is given. Now this second B just means that this is the B value if C happens to be not obtuse. Okay, and so if you look at C1 right here, you'll notice that it is related to C2 over here in that C1 and C2 are supplementary to each other. Okay, so let's go ahead and build out the first example here. I say build out because it is a long process. Okay, so let's say we look at the first example here and we are given an angle and 2 sides where angle A is given to us. We have 2 sides with the angle not being included. So how do we know that this is the ambiguous case? Is this the ambiguous case? The answer is yes. And it is because it fits the description of SSA, where A is not included. Okay, we're going to set up and solve for the only thing we could possibly solve for, angle B. So our initial, just like law of signs on the first video, we always start with what we know the most of, and that's going to be A. So we're going to do sine of 34 degrees over 8 is equal to, and the only possible angle that we could solve for here is B. So we're going to go ahead and set it up as sine of B over 10 and do cross multiplication and solve for the angle measure, in which case you get sine of 10 sine of 34 equals 8 sine of B. And again, I encourage you to keep your angles, keep your calculations so it's at the very end that you would be solving for B. So if this was me and I was working with the calculator, I would be solving for sine of B as sine of B equals 10 sine of 34 divided by 8. And then to undo sine, we're going to take the inverse of sine. So inverse sine of 10 sine of 34 all over 8. So this is what I would enter in on my calculator to figure out what angle B is equal to. And keep in mind that we always have to consider that this possibly might result in two triangles. So this is my first possibility for angle B. So I'm going to say case 1 of B is it's equal to, punch that into the calculator, we should get 44.346. Now, if I go back to this picture, B1 is what I just solved for. That's case 1. So it's a possibility, that's why it's ambiguous, that we might have a B2, a second B value. So to find that second B value, this is always the case when you get here, is it should be supplementary to B1. So what we do is we take 180 minus 44.346. Okay, and that's going to yield the solution that the second triangle might have a B value of 180 minus B1, or if I punch that into the calculator, I get 135.654 degrees. So just to recap what we have so far, angle A was given to us. That's going to be fixed no matter whether we have one solution or two solutions. So 34 degrees, remember those are the fixed parameters. B1, in this case, the first B value I solved for was 44.346 degrees. The second B value was supplementary to that, so 135.654 degrees. And then if you guys note that this is one triangle, and then this is the scenario if there was two triangles with those that fit the initial parameters, how would you find the third angle? Well, you'd simply add A plus B1 and then subtract it from 180. So 180 minus 34 minus 44, remember, three angles of a triangle add up to 180 degrees. So we get 101.654 degrees. We do the same thing on the other side, and keep in mind that's C1 for the first triangle. So for C2, we do the same thing. Here's the step where if you were to subtract these values and you end up with a C value that is negative, at this point you would say it doesn't exist. The second solution, the second triangle, doesn't exist, so therefore there was only really just one triangle that fit the parameter. However, when I take 180 and I subtract 34 and I subtract 135.654, I actually get a positive value, which means there really was two triangles that existed with the initial parameters that were stated at the beginning, with the 34 here, the 10, and then the 8. So to find the third side, so the only thing we're really missing now is this third side, which is C. And I'm going to say that because we got to the point where there's a solution 1 and a solution 2, we're going to figure out a side C that is C1 and C2 lowercase. So to do that, I always use the initial setup of proportions with what was given in the diagram. So the A values, so sine of 34 over 8 is equal to sine of C, And for this one, I'm going to use the C1 right there. So 101.654 all over the little c, or side c. And if you guys go ahead and solve that by multiplying, cross-multiplying, and isolating C1, you should get, and I encourage you guys to try it on your calculators to make sure you match the values that I have. One of the things I know when I did it with my SLGOs is that they were entering it into their calculators incorrectly, getting the wrong answer. So just making sure that you can get to the correct answers from the proportion. So for solution 2, instead of the 101, we use C2. So remember, the initial parameters are still the same for both triangles, so I can use my A's. And when I do so, this time I'm going to use 10.346 all over C, but this time I'll call C C2 because this is the second triangle. And I should get 2.569. So that's going to give us all of our values that we need to show that there's actually two triangles that exist. So I'm going to say 2 triangles exist for this one, and list out for you all of the values that are true for each triangle. So remember, what I mean with the given parameters must be the same is that whatever was given to us at the start is the same for both of these triangles. So that includes big A, little a, and then little b. In the process, we found out what B1 was, and that's 44.346. The angle C1 is 101.654. Little c is 14.011. And then for the second triangle, we found that there was a second triangle that existed because when we found the second angle, we were able to determine that the third angle existed from the fact that the sum of all three added up to 180, and then little c, the side c, was 2.569. Okay, so how would I know that? We talked about the fact that at step 3, if I were to find the third side and found that the third side, or I'm sorry, the third angle didn't exist because it was negative, then I would know that, well, there was only one solution that worked. The question is, how do I know that no triangles exist from it? So if you're in step 1 and you're trying to solve for, say, and I'll highlight it, this step right here. If you were trying to solve for inverse sine of b, and you entered in a value that wasn't in the domain of the inverse sine, then you're going to get an answer in your calculator that says undefined, in which case there is no angle measure that exists that would actually form a triangle from the given